dividing polys. And the remainder theorem. And the factor theorem. All right, to start this chapter, we want to talk about when we'd want to factor when something is beyond the scope of what we've learned to factor so far. So in the example in the book, they talk about a moth. A moth gets into your home and it lays 200 eggs. And you want to know, is this possible? Given that you know that the function of how a moth lays its eggs is this function here. Where x is the width of the moth, and we know x is between 1.5 and 3.5. And we want to know, is 200 possible? So really what we're asking is we're wanting to know if we can find the zeros of this equation here. And what we do is we move the 200 over, and then we would proceed to factor. Well, the problem with this, if we look at it, is that we don't know how to factor this. There's no really trick that we've learned to factoring this. And so we're going to go over a new trick, a new way of thinking about these problems. It doesn't always work, but in order to solve this problem, we need to talk about long division or dividing of polynomials. So that's what this chapter is about, is dividing polynomials. Okay, and dividing is essentially we're factoring. I want to know is something to factor. If not, has a remainder. So first go over some basic stuff when it comes to functions. So if we're taking a function, a polynomial, and we're dividing it by some other poly, we'll call this g of x, and we'll have our quotient, and then we'll have our remainder. Okay. So this right here is known as the dividend. This is your divisor. This is what you're dividing by. This is your quotient. And this is your remainder. Okay. So that's how it's going to look when you're done. Hopefully, we'll have the remainder, this right here. Hopefully it'll equal 0, in which case we have no remainder and we've actually found a factor, in which case the divisor, this would be a factor. This right here would be a factor. Okay, so to start this off, let's just propose a question. We want to divide, so we have x plus 3. We're dividing x plus 3 into x squared plus 10x plus 21. And we know this actually works. We can factor x squared plus 10x plus 21. It factors down into x plus 3 and x plus 7. So we know that when we're done, we're going to have an x plus 7 on the top. But example here is to do something simple first. But before we do this, I want to remind you of long division with just regular integers. So here we're dividing 26 into 3,983. And the first thing we would do is we would, does 26 divide into 3? No, 3 is smaller than 26. Does it divide into 39? Yes, it divides into 1. So we were at a 1 here, we're at 26 here. Then we do our subtraction, and we'll get 13, carry down the 8. Now we're asking how many times does 26 go into 138? And it'll go in 5 times. Okay, now we do our subtraction, get an 8, carry down the 3. And we're wondering how many times does 26 go into 83? Well, it goes in 3 times. We do that, you get 78. then do your subtraction. You have 5, so then you have a remainder of 5. Now, so this is a review of your normal division. It's going to work out the same way with polynomials. You're going to do your subtraction, and you're asking yourself, what does this binomial in the left-hand side, what do we multiply it by to equal whatever's in the right-hand side? So it's the same process, it's just same thinking, except you're thinking in polynomials instead of in integers. So let's try this out. We have x plus 3, x squared plus 10x plus 21. And so, except you're going to look at, since we have a binomial, we're going to look at binomial pairs. So x plus 3, can it divide into x squared plus 10x? Yes. And what we're going to do is we're going to multiply the whole thing by x. See, x times 3 is 3x. X times x is x squared. Okay. And then we're going to do our subtraction, which is change our sign. Notice these will cancel, which is what we want. If we've done it right, these will cancel. If not, then we need to change this x up on top here. Okay, now we ask ourselves, what times x equals 7x? Well, it's going to be plus 7, so we're plussing 7. And we multiply both the 3 and the x by 7, so we get 21, and then 7x. And then we change the sign, just like we did above, and we get a remainder of 0. So we know it factors. So x squared plus 10x plus 21 divided by x plus 3 has a quotient of x plus 7 with a remainder of 0. Okay, so there's your simple example. Let's move on. What happens when it's a little bit more complex? So next problem here, we're going to divide 2x to the 4th plus 3x to the 3rd minus 5x squared plus 2x minus 5. We're going to divide it, by 2x plus 1. So set it up. 2x4 plus 3x cubed minus 5x squared plus 2x minus 5. And over here we have 2x plus 1. So looking here, notice we're not missing any exponents. If you do, you'd need to put them in to use this method. So if we didn't have an x cubed up here, if we didn't have an x cubed, we'd need to put a 0x cubed in. But we do, so we don't have any zeros in. So now, what times 2x will give you 2x to the 4th? So what times this will give you this? All right? Well, that'll give you an x cubed. If we take x cubed multiplied by 2x, we'll get 2x to the 4th. So we're going to take x cubed. And we're going to multiply it by this term and by that term. So x cubed times a 1 is an x cubed. X cubed times 2x is 2x to the 4th. Now you do your subtraction, so you change both their signs. Since they're both positive, they're going to become both negative. Here it cancels, which is what we wanted. And then 3x cubed minus x cubed is 2x cubed. Bring down the negative 5x squared. Okay. Now, we ask ourselves, what times 2x cubed, what times 2x will give us 2x cubed? And that would be an x squared. So if we add an x squared, okay, so x squared times this 2x here, times the 1 here, that will give you what you're looking for. So x squared times 2x is going to give you 2x cubed. X squared times x is going to give you an x squared. We change both their signs. Here they cancel, which is what we want. Here, since they're both negative, they're going to add together. You're going to get negative 6x squared. Then you're going to bring down the 2x. Okay? Now, we ask ourselves the question, what times 2x will give us negative 6x cubed, or squared. And that would be a negative 3x. Okay, if we multiply negative 3x, if we multiply this by this, we will get this right here. Okay. So let's go ahead and do that. So negative 3x times negative, or 2x is negative 6x squared. Then negative 3x times 1 is negative 3x. Now they're both negative, and we have to change the sign here. So here, since they're both negative, and we're changing the sign, like we did above, we're going to make them both positive. Okay, here they cancel, which is what you want. And here you're going to end up with 5x. Now you carry down 5. Okay. Here is where it gets a little bit harder than normal. We're wanting to know what times 2x will give us 5x. Well, notice nothing times 2 will give you 5 as far as regular integers go. So we're going to have to use fractions here. What times 2 will give you 5? Well, the answer is 5 halves. If we take 5 halves, okay, so we're going to add 5 halves. If we take 5 halves and we multiply by 2, I'm going to do it over here on the side here. So 5 halves times 2x. What does that give us? Well, the 2's cancel. That'll give you 5x. So that's what we need. We need this 5 halves. So 5 halves times 2 will give you 5x. And then 5 halves times 1 will give you 5 halves. Then we change their signs, so this becomes negative. This is also negative. Here they cancel, which is what we want. And then we are left figuring out with what negative 5 minus 5 halves is. Well, they need a common denominator. Common denominator is 2. So we can rewrite this as negative 10 over 2 minus 5 over 2, which gives us negative 15 over 2. Okay, and that would be our remainder, negative 15 over 2. And we can write this as minus 15 over 2 divided by 2x plus 1. And you could simplify this by keep, change, flip. You keep the 15 the same, flip this guy over, multiply it by the 2. So we could rewrite this as minus 15 over 2 times 2x plus 1, all right? Or negative 15 times 4x plus 2, if you will. So this bottom one here is in the simplest form, and some teachers will only accept that or software, but either answer is correct. Okay. All right, so there's long division with a little bit more difficult problem. Let's talk about a different way of doing division, and it's called the synthetic division. The thing with synthetic division, it only works if you're dividing by something that's x minus c. So if we're dividing by an x plus 5, or an x plus 3 halves, etc., or x minus 4. It won't work if, however, you're dividing by 2x squared minus 4. This process in synthetic division won't work. You can modify it so it will, but that's beyond the scope of this course, so we won't. So we're looking for these types. Hopefully we don't end up with one of these, because then we have to do fractional arithmetic, which is within your ability, or it should be. So let's look at an example of synthetic division. Best way to show you how to do this is just to do it. So I'm going to take x cubed minus 7x plus or minus 6. And we're going to divide it by x plus 2. So this is in the x minus c. The plus or minus doesn't matter because we can rewrite it. Okay. Now, when you're setting up synthetic division, what you're going to do is I put an upside down division box, and we're going to take the c part. Now, c here is 2, right? But you always do the opposite sign. Since it's plus 2, you're going to do minus 2 over here. And the reason we're doing that is we're changing our sign at the very beginning instead of every step. In long division, we changed it each step. We had to change our sign. So if we do it first, then we won't have to do that step. So it saves us time. And then what you do is you write out all, just using the coefficients, you write out the coefficients. And if you are missing a term, like here we're missing an x squared, you're going to have to put a 0 in. So here we're going to have a 1. This is for your x cubed. Then we're going to have a 0. This is for your x squared. So this is your x cubed. This is your x squared because we don't have an x squared. Then we're going to have a -7. That's your x. Then you have your constant term, -6. Okay? So we've set it up. Then what you do is you bring down the 1 here. And then we're going to take this 1 and we're going to multiply it by the -2. So 1 times -2 is -2. And you add these together. 0 minus 2 is -2. Then we're going to take -2, multiply by 2. So we're going to take this, multiply by this. Okay? And that'll give us 4. And we put the 4, put the 4 here. And then we add these. What's -7 plus 4? It's -3. Okay? Now we take the -3, and we're going to take this -3, and we're going to multiply it by the -2. And that gives you a +6, and you write it here. Oops. Six. Then we combine them, and this would be our remainder term. We have no remainder, so it's 0. Okay, and then we could write out our answer. So the answer is here, it's going to be 1 less in power. So this is your x squared term, your x, your constant term, and then your remainder. So our answer is, if we divide this x cubed minus 7x minus 6 by x plus 2, the answer is x squared minus 2x minus 3. Okay. And then, so we could say the factor of this is x plus 2 times x squared minus 2x minus 3. And if you wanted to continue to factor, which is what prep this, you would just factor this. Okay. Take a break here and get some water. I'll be right back. All right, let's do another one. Say we want to do this. We want to use synthetic division. So we set it up. Notice it works. This is a binomial. And we're going to put a 3 here. We're going to take the opposite sign. Then we're going to put a 1. Put a 0 in for the x cubed, minus 3, 1, and -4. Then we're going to bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. -3 plus 9 is 6. 3 times 6 is 18. 1 plus 18 is 19. 3 times 19 is 57. 57 minus 4 is 53. So this has a remainder. So our answer, this is our cubes term, squared, x, constant, remainder. So it's x cubed plus 3x squared plus 6x plus 19 with a remainder of plus 53 over x minus 3. Okay. Okay, so that's it with synthetic division, and let's move on to remainder theorem. Let's say all we're really interested in is the remainder. They have a question like, what is the remainder when you divide this polynomial by this binomial? So this is, again, remainder theorem. It's working when we're dividing by an x minus 3 by this binomial. Okay, and it's a binomial where the coefficient in front of the x is a 1. So there's a 1 here. Okay, so example is, what happens if we're going to we have f of x, which is And we want to know what the remainder is when we're dividing by x plus 4. Now, we could just plug this in and solve it using synthetic division, but the remainder theorem says it's a shortcut. So since we're dividing by a binomial with the constant coefficient in front of the x of a 1, all we have to do is plug in this negative 4. So the remainder theorem states the remainder is going to be this f of c will be your remainder. And that's what the remainder theorem says. So you're going to, again, choose the different signs. So if we want to know what this f of x divided, what the remainder is when divided by x plus 4, we could answer the question is, what is f of negative 4? So again, it's the opposite sign of this 4. So what's f of negative 4? So you're going to plug it in. And when you work it all out, you will get a negative 105. So remainder is negative 105. Okay. So that's all the remainder theorem is stating. There is the factor theorem, which is built off the remainder theorem, states that if we're, again, dividing by a binomial with a 1 is your coefficient in front of your x, if f of c equals 0, then x minus c is a factor. That's all the factor theorem states. It's basically saying if there is no remainder, then x minus c is a factor. So this allows us to check for factors without actually factoring it out when we're doing this, when we're factoring by a binomial with constant coefficient of 1 in front of the x. Okay, so let's say we want to know, we have 15x cubed plus 14x squared minus 3x plus 2. We want to know what the factor is. Say we want to know is x plus 2 a factor of this. Well, all we'd have to do is plug in, this is your f of x, just plug in f of 2, okay? And if f of 2 equals 0, then it is a factor. So instead of trying to do our long division and seeing if it actually divides out evenly, we could just plug, well, it should be negative 2 here, my bad. It's always the opposite sign, f of negative 2. So we're going to do 15 negative 2 cubed plus 14 negative 2 minus 3 negative 2 plus 2. So here you're going to have 15 times negative 8 negative 28 plus 6 plus 2. And we can easily see that this will not equal 0. This does not equal 0. So then we could say that x plus 2 is not a factor. Okay? So that is the factor theorem. Well, that is it for this chapter. I hope it finds you guys well. Talk to you later.